Welcome, everyone, and thank you for joining us for today's webinar, Graph-Powered Machine Learning, an interview with Dr. Alessandro Negro. My name is Meryl Lee, and I'm part of the webinar team here at Neo4j, and I'm joined by our guest and author, Dr. Alessandro Negro from GraphAware, and Amy Hodler, Director of Graph Analytics and AI Programs at Neo4j. A quick note regarding questions before we get started. We invite you to submit any questions you have throughout the interview using the Questions tab located at the top of your screen. We will be weaving your questions throughout the presentation, and if we don't get to yours, someone on the Neo4j team will reach out to you directly, or you can send an email to webinar@neo4j.com, and we'll get you pointed in the right direction. I also want to let you know that this interview is being recorded. With that, I'll go ahead and hand it over to Amy.
Great, thank you. Thank you, everybody, for joining us. We're here today with Dr. Alessandro Negro. He's the Chief Scientist at GraphAware. As many of you know, Dr. Negro has been a longtime member of the Graph community, and he's the main author of the very first recommendation engines based on Neo4j. So at GraphAware, he specializes in natural language processing, recommendations engines, and graph-aided search. So thank you, Alessandro, for joining us and agreeing to talk to us about your recent book, Graph-Powered Machine Learning.
Thank you, Amy. Thank you.
Yeah. So I want to start off by talking about the book itself, or hearing a little more about the book, because graphs and machine learning is a big topic, and you could have gone in many different directions with this book. So can you describe the focus of the book and who it's written for?
Yep. So the book is for people like me 7 or 8 years ago. I was approaching the world of graphs, having some background, even some small background actually, on the basic principles of machine learning. And so I know perfectly the feeling, what are the key issues you have when working on big data, and you would like to discover new and more effective approaches. So the book is following more or less my journey with the graphs and machine learning. And this is a clear idea. It is very easily recognizable in the book. Because as you said, I started working with recommendations, first without graph, and then I discovered the power of graphs and Neo4j specifically. And I was like, this can be an interesting approach. So I worked on this first ever recommendation engine built on top of Neo4j. It was called Rico4j. And that's why there is a big part in the book talking about recommendations, since I used it a lot in different shapes, actually. So after recommendations, I added other scenarios and use cases related to fraud detection that leverages a lot of graph algorithms to spot outliers. So in that case, fraudsters, since in my opinion, it is a very good use case. While the last part is related to something that belongs to my heart since 4 years now, from 4 years, we are working on today's product that is called YUM, that is a graph-powered insights engine that leverages graph-based natural language processing techniques and knowledge graphs. So the last part of the book is more related to this experience in in this area. So more or less, it is a journey that is actually my journey. Let's say that I hope that this will be helpful for other people that are struggling as I was some years ago, actually.
Okay, well, so I think you've already answered my next question here, but I guess can you talk a little more about the motivation for the book itself, beyond written for somebody like yourself? Like, what actually there's a lot to be said for the commitment that it takes to write a big book like this. So what motivated you to actually commit and say, hey, we're gonna go forward with this?
I would like to share my experience, and at the same time, I would like to have a mechanism to rethink my journey and organize all my ideas, all my experiments in the graph space related to machine learning. So let's say that I tried and failed so many times that I wanted to avoid other people to do the same in their approaching graphs and machine learning. So I also needed something to put together all these ideas in a way in which they can be clearly stated, written black and white, and actually can be helpful for other people to approach these problems that are complex, definitely, in a way in which they have some of the key issues already resolved. So it was, of course, for me, as I said, but also for other people to avoid to redo the same mistakes that I did in these years, actually.
Okay, so we've got a fun question from the audience, or I hope it's a fun question for you. What's the biggest mistake you made? You mentioned mistakes, so what's the biggest mistake you made so that I can avoid it?
Well, definitely the one is that when you are testing something with a toy example, you hope that it will work once you will get in production. So, and this is clear in the book also, because I tried to use data sets that are not toy data set. They are real data sets with tons of data in it. And you will notice how, there are some tricks for importing data in a proper way, for example, with multi-thread writing at the same time in Neo4j, some small changes in the models to avoid the concurrency. This means that, I did a lot of mistakes along the path. And of course, these are the most common, because in a lot of books you can find, toy example. In a lot of blog posts you can find toy example. And when you use it in production, as I did, so many years ago, you can discover that they cannot work at all, because you have to take into account the scale of the problem that you are going to approach. And when you are talking about machine learning, this is a critical aspect, actually. It's not just a case that it will be a problem.
Well, we appreciate you making the mistakes for us and being kind enough to share them in your book. So the next question is really just about the overall role between graphs and machine learning itself, and how you view that.
Let me say that the role of graphs in the last 10 years mostly changed a lot, and is continue to change, actually. At the beginning, it was one of the other NoSQL database. Remember the book about NoSQL Distilled from Martin Fowler and Salalaj. It was one in the list, actually, because people were trying to solve some of the issues that they have with the classical DBMS in a different way. So they had different solutions, and graphs were one of these approaches. But this changed a lot in the last years, I would say. And under this perspective, we are lucky, because we are following this journey of the graphs, and actually it is also our journey. And I'm referring to Neo4j and GraphAware, for example. And we are lucky for two reasons. First of all, because of course, we were there at the beginning, and we are still here, looking at the way in which this role is evolving. But also we can do our best to support these changes. So we are developing libraries like the Neo4j library, GDS, so the Graph Data Library, Data Science Library, for supporting graph algorithms on Neo4j. We are working on this product called YUM, that is supporting the textual data processing on top of graphs, actually. And, in this way, with our books, with blog posts, even convincing our customers that the graphs are the future, we are trying to change the world. Maybe that I'm just a dreamer. So in this evolution, we can say that now graphs are playing a key role in the machine learning panorama, specifically with some good examples such as knowledge graphs. Because, these knowledge graphs are allowing people to gather their data currently distributed in multiple data silos in one single connected source of truth. And then on top of this, together with the contextual information that graphs can bring together, they can create a new type of machine learning applications, actually, that before were just, in their head. And so graphs are really opening their mind to new ideas, to new opportunities. So definitely the path is the right one, and I'm seeing much more in the future if you think about deep learning and deep learning maybe in the next iterations.
I'm really glad you mentioned knowledge graphs, because I do feel, and it's something that my team talks a bit about as well, is that you have to get that information together in a way that you can then use for other purposes. We often say that knowledge graphs are the foundation for graph data science and help us kind of walk through that path that you mentioned. So I'm glad you called that out. I do have a question about a little farther future looking, like how do you see, are graphs going to change the way machine learning is done in the future? If so, how? Or are machine learning going to change the way we do graphs in the future? So that's kind of an interesting question for you.
Definitely. Let me answer to the first one. Let's say that one of the biggest issues in the machine learning is data management. Because if you look at some, let's say, statistics, the 80% of the time of a data scientist is related to dealing with the data, gathering them, cleaning them, and then extracting features that are relevant. In that sense, for example, graphs can help a lot, and knowledge graphs can help actually even better, because you can collect your data even without pre-think about what will be your use case. You can just collect the data that you have. And then with this fast access that you will get thanks to the, let's say, to the graph structure, actually you can then design multiple machine learning projects or machine learning algorithms that will act on this data. And differently than what was happening, for example, with data warehouse, in which you have to pre-design the access pattern that you have in mind, because you need to design this star schema. In the graphs, actually, this is not necessary, because you need just to organize them properly in a reasonable way, I would say. And then every single node and every single relationship can become your access point to your analysis. That was impossible before. In the other way, I would say that GDS is a good example in that sense, in the way in which machine learning Panorama is acting on top of a graph database provider, for example, in order to provide new features. And because this is a library that helps concretely people to focus on their business, because community detection, for example, or finding the shortest path, it's becoming a sort of commodity that you can get out of such a database such as Neo4j, for example. And people can focus on more advanced services built on top of this. And that's definitely a good way to think about the way in which, let's say, external processes are in some way changing the roadmap of a product like Neo4j or other graph databases, actually.
Great. That interesting direction. Thank you. Another question here is about the focus on common techniques. So I'm really passionate about context for machine learning. So I was glad to see that in the book quite significantly as well. But you call out 4 common techniques for recommendations. So can you give the audience an overview of what those 4 techniques are?
Sure. It is a sort of a path from more simple approach to more complex approaches, not only in the sense of understanding them, but also in the sense of the amount of data that you need to store and process in order to work on these algorithms. So in this sense, the content-based approach is the simplest. You need the item description and user profiles, and you can provide a recommendation. While collaborative filtering approach requires much more data, I would say, because you need to have this user item interaction in order to create a proper model. And in this sense, of course, it can provide even a more accurate recommendation than the content base. Session-based, on the other side, it's something that I wanted to add since I had some issues for a customer when he asked us to provide a recommendation, but they didn't have any user stored because the most of the users were anonymous during the navigation. So we had to invent a mechanism to provide recommendations, even though we don't know anything about the users. And then we approached this mechanism or this algorithm that then I discovered writing the book, that is called session-based recommendation engine. And so I wanted to put it as an alternative approach to the collaborative filtering once you have sessions instead of users. Context-aware, instead, it's one of my favorite, actually, because it takes into account the contextual information and to provide the right recommendation. For example, in my case, when I'm alone, I prefer to see horror movies or action movies. But when I am with my family, for example, we prefer, I don't know, cartoons or family films, of course. So this is an example of how much the context influence our decision, actually. And in this case, also, there is a perfect match with the graph, because as you know, storing the contextual information in the graph is a trivial exercise. So I wanted to express this clearly in this chapter about context aware. Finally, the hybrid recommendation is a sort of a mechanism for putting all these things together. Because via a switch, for example, or a weighted mechanism, you can start with a content-based algorithm because maybe you don't have enough data, and then you can easily switch or weight differently a collaborative filtering approach that could be better, but you need to have more data, of course. This is a sort of journey. And of course, there are tons of examples in which graphs can be a concrete help in this. You can store the many sources of data, as I said before, and you can actually store the models on top of it, and then you can access in an efficient way. And this is a critical aspect because it's not only, performance in the machine learning case doesn't mean only, the accuracy of the model, but it means also the speed at which you can deliver such recommendation. Imagine to recommend something to a user after 3 minutes. He's already gone, So this is how much critical is the performance aspect. And in this sense, graphs providing a fast access to the data provides you what you need in terms of performance also.
Great, thank you. I have a question from the audience. So you talk about several different models. How should someone choose which one to start off with? Is it easier to get started with the content technique, or what would you recommend?
Definitely, the modeling part is the more exciting part, I will say, because it's true that graph databases can be considered schemaless, but the reality is that the way in which you will structure your data affect the way in which you will access this data. It's also true that in graphs, you don't have to be right at the first iteration, actually, because if you design the first example, the first model, even though it is not the best one, you can evolve it over time. And in most of the cases, you will not need to change all the applications accessing to that dataset while you are evolving it. And this is another advantage. But in general, I would say that graph modeling, it's a key component of the way in which you are approaching this world, because it is definitely something that you need to take into account the most, because it is the initial part, actually. Yeah. So, and that's why there is a lot of examples in the book for different scenarios, for different use cases.
So this was a perfect lead into my next question for you, was just the covering the model in quite a bit of detail in the book. So I'm glad the audience picked up on that as well. Is this something you find people actually struggle with, or is it just like maybe time consuming?
Definitely, they are struggling with this data modeling, because graphs, by definition, from a mathematical perspective, are very, very simple. They are just nodes and relationship. Of course, in case of Neo4j and this label property graph, you have also some other tools like labels or properties that help you quite a lot. But as I was saying, this doesn't mean that you can do what you want, actually. Yeah. There are, the same problem can be modeled in tons of different ways. There is not, let's say, good or bad solution. It's just the solution that fits your needs. So while you are modeling your graphs, actually you have to think about the way in which you will store the data, the way in which you will actually access the data. So you need to think about the questions that you will ask to your graph database while you are modeling your data. And as I said, likely you can evolve the graph, but let's say in some way, it's not that you have to, you cannot change, let's say, all the model in one shot. You need to slowly change from one step to the other, and you need to be careful, let's say.
So personally, I found that in particular, the context-aware model or recommendation engine really interesting. And so I wanted to tease out whether there are particular design considerations for that model that people should be keeping in mind.
Well, I found very useful in the case of context-aware recommendation to pre-compute some models, because once you add contextual information, actually providing recommendation could be actually a complex task, because you need to take into account the contextual information while you are creating the model and the current context of the user. So what I found very useful in terms of modeling the way in which you are providing a recommendation is pre-computing some of the possible let's say, combination of the contextual information that you can have and store them in the graph. And in this sense, again, the graphs can help you a lot, because you can store multiple models quite easily in the graph, and then you can access in the way in which you will find more comfortable. And in this sense, this capability of the graphs to store multiple models at the same time actually helps a lot during the hybrid process, because with a single query, actually, you can perform, let's say, this hybridation process without having to create a complex pipeline of work. So in these two cases, actually, you can recognize the power of graphs in helping you to access properly the, let's say, the models that you created, the prediction models that you create during the prediction phase, actually.
So for those, I guess, next question here, for those people that are just getting started with machine learning and graphs together, but on checking out your book, which is a fantastic resource. So beyond that, is there some advice or tips that you can give them to, just start their own journey?
In that sense, I will definitely suggest your book about graph algorithms, because it is really a very good introduction to one of the most powerful graph library that I have ever seen. So if you like to approach, the graph and machine learning, and definitely approaching from the graph algorithm perspective, it's a good starting point. Apart from that, unfortunately, I have to say that there are not so many books trying to, let's say, filling these gaps between graphs and machine learning. So in that sense, I will recommend a lot of blog posts, most of them which are available on Neo4j website or even on GraphAware website. Then if you like to go more in deep, you have actually to go through the scientific literature, and or join some community. For example, even in this case, Neo4j has one of the best community of experts in that sense, because you can get an answer to any question in the most of the cases, actually.
So I have an audience question for you. It's an interesting one. I hear a lot of people talk about thinking in graphs. What does that really mean? And how can I do that or do that faster?
That's definitely an interesting question, because what I generally like to say during conference or the opportunity in which I can suggest something, I mean, if we have let's say not so young people that work along with data warehouse, for example, or with relational databases, first of all, it's required a mental shift. In which you have to think to a different way in which you are modeling your world, actually. Under some perspective, this way of modeling your words via graphs, it's even simpler than before. But when you have such a background in which you were forced to think in tables, for example, you could have actually hard time to reset your mind to start, drawing just a node on a whiteboard, and that node represents a physical entity. So it's a person. It's not a type of a person. For you, it could represent Alessandro or Amy. And this is the hardest part in the journey of migration from classical approaches to this new graph-based approach. And so you need to be conscious about this. You need really to clean your mind and approach the new journey from a different perspective.
Nice. I think there's a phrase, empty the teacup. So great. I love that suggestion. Clean your mind. It helps get started. So I just want to make sure people are aware your book, Graph Powered Machine Learning, is available now, or at least partially available now, through Manning, the publisher, in their early access program, and also Neo4j, who's made a excerpt available that you can get now. And I'm curious, what kind of early feedback, because it is available as an early access program, what kind of feedback are you receiving already?
I have to say that I love this MIP idea, and I also love that you are giving an excerpt of my book to people that are interested in it, because this is concretely giving the opportunity to people to start, reading the book before I will finish it. That is even removing a lot of pressure on me under this perspective, since I'm working on this since 3 years now. Definitely, I have to say also that the most common feedback is related to the language, because I'm not a native speaker, so I can recognize this pattern in the comments. I'm sorry for that, but the copywriter is doing her job in correcting all these mistakes. Jokes apart, people, I think, really appreciated the topic, first of all, because even in my words before, you can notice how this was a sort of a missing book, really the missing ring of conjunction between two different words. And this is opening their mind. Remember the concept of mental shift that I was mentioning before. This is really opening their mind, bringing new ideas, new ways of using the best of these two words. And as I said before, I like thinking that in some way this book is helping us to change the world somehow, because people can get really a lot from these graphs. And the feedback that I'm receiving from people that just connecting me via LinkedIn, for example, or commenting on these MIP channels, it's really in that sense. They really appreciated the ideas, the content that they can just get and use for their work, because maybe their bosses asked them to start investigating about new approaches to solve complex issues, and they found useful this book. So this is really my greatest satisfaction, when they just ping me and say, you saved my life, because my bosses was almost kicking me out because I cannot find the proper solution to a common problem, it appears.
Great, thank you. And an excellent book. I think your point about helping people shift the mind and being a resource so people can actually get started is spot on. So we appreciate, like I said, you making those early mistakes and making sure that helping people avoid doing that later. So a question I really am always interested in, especially with other authors, is what surprises did you come across as you were writing a book?
A lot. I mentioned already one example before, because when you write a book, what you have to do is to give power to your ideas in some way. And so what I did constantly in the book was to find other people that found a similar solution to a similar problem, actually. And while I was scouting the web, I would say, or the scientific literature, searching for common solutions, I found that what I found as a good practice, it was a best practice actually. So definitely this was surprising me quite a lot. You know, discovering that other people found a common solution to your problem. I said already the example of the session-based recommendation that I used as a session-based, and I didn't know that was the name. And that's why also in the book there is so much reference at the end, because I wanted people to see what other people did in the past, or if I mentioned, let's say, an experiment as one of the best thing to do, I would like to that they can go there and see that it's not only Alessandro saying this, but also maybe 2 or 3 other people saying the same. So this, and in a lot of cases, I found references where I thought that there was no reference at all. So that was definitely one of the most surprising aspects of writing a book. The second one was definitely that I was able to finish it. That was the biggest surprise at the end of the day, to be honest. So,
okay, I'm not surprised you were able to finish it. That doesn't surprise me. But I understand how long that takes. So is there anything else that I haven't asked so far that you were hoping we would discuss, or you'd like to share with people?
Well, I will just conclude saying that this is a book that doesn't require to be read cover to cover. It is a book that has to be used. You can take what you need, actually, and when you need it. All topics are not only theoretical topics, so they are concrete. They are real use cases. They have code with queries and things that you can just take as they are, adapted to your needs and use in your use case. So definitely, it's not a book that you can just read once and put in your or your desk or wherever you prefer. But it's a book that will constantly be useful because maybe that today you are doing recommendation and tomorrow you are doing fraud detection. So use it when you need it. Actually, that will be more helpful for your experiments or for your machine learning projects. That's something that I wanted to mention because it will be a different way of approaching the read of this book.
Great. Awesome. And I often tell people I'm hoping that they mark up the books, dog-ear the pages, tear out a page and put it aside if it's that useful. So we've had questions come all along, and I'm afraid I think we only have time for one more question. So the last question that's with lots of exclamation marks is, when is the code available? So you have some fans out there waiting to look at the code you've used.
I will say soon. Actually, I'm asking a couple of people to reviewing it, and to be honest, since I started 3 years ago, even Neo4j changed a bit in these 3 years. So I have to adapt the first version of the code to the newest, and the nicest thing available in Neo4j. So it will be available soon. And to be honest, to someone that asked me to have an early access, I grant them access. So if someone would like to get an early view of this, let's say, code, just ping me in all the channels that you will find useful, and I will be more than happy to share the code with you. It's not time yet for making it public available, but definitely, it's not a secret, so I can share.
Okay, great. So you guys heard it here. You can get it if you contact Alessandro. Wonderful. Well, thank you very much for your time. Appreciate it. Thank you for writing the book. It's a wonderful resource. If the audience hasn't taken a look at it yet, they absolutely should take a look and use the examples that Alessandro has provided.
Thank you, Amy, and thank you, Neo4j.
All right, thank you both, and thanks to our audience for joining us today. If your question wasn't answered, you can shoot an email to webinar@neo4j.com. We'll get you pointed in the right direction. And with that, I'll wish everyone a great day, and we'll see you on our next webinar. Thanks so much.
Thank you.